All right, good morning, and welcome to the next unit in our quest to understand more about computer programming and computer science, AP Computer Science A, where we are going to start discussing objects, which is a really big part of programming, modern programming that is. I'll kind of talk a little bit about the difference between object-oriented programming and procedural programming, which is basically most of what we've been doing up to now in a later video. But today I'm just going to kind of give you the rundown on what do we need to just get going with programming objects and creating our own objects, and yeah, basically what does that code look like, and what's the usefulness of it. So without further ado, let's start talking about objects. So first, what is an object? So in programming, objects are pieces of code that combine together state and behavior into one file, into one class. So you want to think about an object as basically, well, it's something that you're trying to model in the real world, you know, be that a car, be that a bank account, be that a student that you're collecting data on, or you know, anything in the world that you can kind of think about is going to have some data, some information about it, and then some functions that thing can perform, or that you can act on that data. Okay, so that is what objects are, and the reason why object-oriented programming is so ubiquitous, why you can see it all over the place, because that's how humans think. We think in terms of objects, and so it's just so much easier to write and easier to read. So that's getting at my next point. Why are objects useful? They're easier to write because we think in this way. The code that you write that's object-oriented is going to be substantially easier to read. So it's going to be a lot easier to read when you've got all these natural names for things, and the functions that you're writing are easy to read, and it will make everything seem like it makes more sense. Okay? And then the world that we live in is object-oriented. So if we can take the world and model it with programming, the way that naturally flows is to use objects instead of just the procedural style of programming that we've been using. And then lastly, and this is less important in this class, but important if you were to go seek a job in the real world programming, object-oriented programming is so much easier for maintaining large bodies of code. And there's features about object-oriented programming we'll go into later, possibly when we get to semester 2. We might not get to it in the first semester, where features of object-oriented programming where extending your code is super easy, and you just find that most companies out there that are software developers are writing their programs object-oriented. They're making these large bodies of code where, you know, all these objects are interacting with each other, and you know that. So I don't know how else to say this better, but the programming world uses object-oriented programming. So if you don't learn it, then you'll be far behind. Okay, so those are all the reasons why we're going to learn about objects and why they're useful. And now let's just start figuring, okay, what are all the pieces that we need? We'll do a simple object together, just a point object, and then in class you'll work on other kinds of objects. So object state. Consider a point which has an x and y coordinate. So this is an example. You know, that little red dot is living at the locations 1, 2. You can think of that point as, you know, just the point. It's just got two numbers associated with it, x and y. What pieces of data are you going to need to describe that point? Now this point has a color, and yes, you could use color too in this, but I think that the simplest way to describe the point, and let's keep things simple for now, we can always add on complexity later when we need to, is that it just needs to know about two integers, one for the x and one for the y. So it's going to have two pieces of information associated with it. A point has two integers for its state. When you're going to build a point, when you want to construct an instance, and we talk about a particular creation of an object, an instance, when we construct an instance of an object, it looks something like this. You say the name of the object, and naming conventions for objects are capitalized, camel casing, so the first letter will be capitalized, point. And then you give it a name, so this is P1 is our name for the point. This is the name. Equals new. This is a word we've seen before. This is how we created arrays. We created arrays using the new keyword. We created scanners using the new keyword. New is what allows Java to know, oh, I need to build something. I need to build an object. And the object that you're building is a point, and we'll talk about these numbers here. These are just, you know, the x and the y for the point initially. So this is, you know, it's starting off at location 1, 2. So this gives us all the things we need to create a new point object, to create an instance of a point object. And that's how you would do, how you would create a point. It would make the most sense this way. Okay, object behavior. So the state is the information that the object knows about. So a point needs to know about its x and its y coordinate. What kind of behavior might a point have? What should a point be able to do? Well, a couple things you might think. Well, maybe you want to be able to print its state. So like print where it lives. So that would be one useful tool, is you can print the location of the point, 1, 2. And another useful tool might be that you want to be able to move it around so that the point isn't just a static, you know, location in space, but it actually could be moved and can be used for in a game to represent the location of a character or whatnot, right? So being able to move it might be useful. And of course, there's more methods you could think of. Anything that makes sense about a point might be a useful method to write to put into this object to give it more behavior. So each of these is going to be a method that we call on a point object. So we've seen method calls on objects before when we did stuff like, you know, scanner. So when we said if my scanner was, say, named scanner or SC, say we called next int on the scanner object. So that took that instance of the scanner object and it went and grabbed the next integer from it. So if it was a scanner that was looking at the console, then it used nextInt to get the next integer from the console. If it was a scanner pointing at a file, which we did in the last one, the Mountain Paths project, sc.nextInt would grab the next integer from the file. So this is calling a method on a particular instance of an object. In this case, for our point, we could do something like p1.translate 3, 2. And so this would move the point 3 units to the right and 2 units up. So, you know, it would move it over here and then up, and so then it would be living at 4, 4. And so it would be nice to have these methods that act on objects. And you could have another method that said like p1.printLocation, which would print out just the point 4, 4, which is where it lives currently. Okay, so this object, you can gather information about it through these methods, and you can change it through these methods. And that's the whole idea around object-oriented programming, is that you can change the state of the object, use it, and also view its contents, see what's there. Okay, so, all right, that's kind of the greater scope of what we're trying to do with this point class. Really, it's simply we're trying to contain an x and a y value that's going to represent a point, and we want some methods that we can call on this point, like printing out where it is and moving it around and stuff like that. So how would we actually write this code in Java? And the way to do that is you create a new class for this object. So a class is basically a blueprint for the object. So it's going to be where we write all the information that the object needs to know about. So we'll write the data that the object will have and the methods that will be called on it. All of the code we write in this class has to work on any instance of the object. So we can have many different points. We could have P1, which is at 1, 2, and we could have P2, which is at 5, 6. We can have P3, which is at 0, 0. So we can have many instances of the same kind of thing, a point, and all of the code we're going to write in the class will work no matter what the point is, where the point lives, which instance of the point we're working it on. So our code in a class will be very, very generalized. It's going to work on the general point. Okay? So this is, you're going to write some public class and then the name of the object that you want to be creating. In this case, we're creating a point object. And it's going to have some data. It'll be the first thing at the top of the class, and it will have some methods which will come after the data. And we'll talk more about what this data means and what these methods will look like. But that's generally what the class will look like for any object you're going to write. It will say you'll have public class, the name of your class, which is camel-cased, uppercased, followed by data, the data that object needs to know about, and the methods that you'd want to use on that object. Typically, classes are going to be written in their own files, so we're going to have a point.java file that only deals with what a point is and its methods, and then we'll have a separate file for actually using the point and running code that uses a point class, our point object. So that's pretty common, is to have two separate files. One for just the object blueprints, the classes, and then, or more, you can have as many object class files as you want, and then something that uses all of those with a main method and so forth. So our point class is not going to have a main method. We're not going to write main in there. Okay, so let's talk about the state some more. So instance variables are the variables that belong to a particular instance of an object. They're going to be variables that contain all the information that represent the current state of that object. So in our point example, its state is its x and y location. So it needs to keep track of that x and y location, and as you maybe change the point around, you translate it, that state persists. It sticks around, and it will be whatever that, it represents where that object lives. So how are you going to create these variables, and where do they go? They're going to go in the data section of the point class. So this comment, you don't need it there, but I just put it there because I want to show you that the data always goes at the top of your classes. So our data will be something like int x coordinate, and I want to note that it just gets declared. We're not actually giving the x coordinate a value. And the reason why we can't give it a value is because this is the general point. We don't know where this particular point lives. In fact, it could live anywhere. You could give it any x coordinate, and that should be fine, any integer for its x coordinate. So we just declare it. We just give it a declaration as opposed to assigning it a value. We'll talk more about how these get assigned values a little in a future slide. So it gets an x coordinate and it gets a y coordinate. So it has two ints that keep track of its state, x coord and y coord. And it's going to have some methods. We'll talk more about methods in the next. You can access these instance variables directly And we'll talk a little, the next lesson, we'll talk about why this isn't necessarily a good thing to do. Sometimes you want to be able to do this, but most of the time you don't. And but you can access them directly using dot notation. So if you've created an instance of a point already, P1, like we did before, then you can print its x-coordinate directly by accessing P1 dot x-coordinate. Okay, so I want you to notice this dot notation we've used before in the past. It's always name of the instance. And so a point object needs to have been created in order for you to reference the x-coordinate. Because it doesn't make sense to reference the x-coordinate of a general point. Who knows where it lives? You have to create a point before you know where it lives and what its x-coordinate is. And P1.y-coordinate would get at the y-coordinate of our point. You can change it. You can change these two. So if you change P1.x-coordinate to 0 and you change P1.y-coordinate to 0, then it's going to move P1 to the origin after this code is run. So that you can print or access these things and change them around directly using this dot notation. We'll see a little bit later, again, in the next lesson, why this isn't always a good idea, and what tools programmers have to kind of combat, problems with allowing these variables to be exposed to other programs. So now let's talk about the methods or behavior that you can write for objects. So instance methods are methods that you'll invoke on a particular instance of an object. So what we said earlier, you can print the location of a point. Again, it doesn't make sense to just print the location of a general point. You need to know you need to have a particular point. You need to have an instance of a point before you can print it. Again, if you want to translate a point, you need to have a particular point to be able to translate it. These are going to be instance methods, meaning they act on one point, one particular point object. And we're going to find that they come in two basic flavors, accessors and mutators. And we'll look at what each of these things are. An accessor method merely provides information about the state of the object. So the object state should not be changed by an accessor method. So of our two methods we've talked about, print location and translate, which one of these makes the most sense as an accessor method? Remember, an accessor just provides information, it does not change the state. If you thought about it, if the accessor makes sense, then you would have thought, oh, it's not translate, that moves the point around, that's going to change it. So I would think print location is going to just provide information. It just accesses the x and y coordinates of the point. So print location would be an accessor method for the point class. A mutator method changes the state. So print location just reads off what those values are. Translate is going to move it around, so it will have a different state after the call. So accessors should not generally change the state of the object. Mutators, their job is to change the state of the object. So accessors and mutators are these two common tools that you'll have for working with objects. Sometimes you just want to see what the object's contents are. Sometimes you want to change the object's contents. And so we have these two methods, two types of methods for that. Another special method is called a constructor. A constructor is a special method that is responsible for initializing the state of the object. So remember how I said earlier that when you create an object, when you're listing out the variables, you don't give them values because they're just general. It's a general point, so you don't know what the x-coordinate and y-coordinate should be. The constructor is what tells that point object what its values will be. So it tells that particular point what the values will be when you call it. So constructors get called whenever you use that new keyword. And the general syntax for writing a constructor is you just say public, and there's no static, and there's no void or int or return type at all. It's just public class name, the parameters you need, and then an open curly brace. You initialize your instance variables inside the constructor. So that's the whole job of the constructor, is to just set those instance variables to values based off of what gets given to the constructor. So for example, our point class, I could write a constructor like this: public point, capital P, and then int x, int y are my two parameters, because a point needs to know its x coordinate and its y coordinate, so the constructor needs to be given two pieces of information. And then inside the point, inside this method, we're going to initialize x coordinate to whatever x is, and initialize y coordinate to whatever y is. And so the point constructor's entire job is just to give values to those two variables, those two instance variables. Let's look at a couple more instance methods. So instance method header have the following form: public. Now it's the next thing we've written many times. All of the methods we've written so far have been static methods. Now we drop the static keyword, and so we'll just say public, whatever our return type is, the name of the method, and the parameters it needs. Okay, so we'll talk more about why that static keyword isn't there in the next slide. But just know that instance methods don't have static keywords. Okay, so they're public, return type, whatever the name of the method is. So for our this should be print location. So for our point methods that we talked about earlier, print location, well, for one, it's a void return type, because all it does is print to the console where this point lives. And so its method header is very short: public void print location. Now you might ask, well, doesn't it need some parameters? And the answer to that is no. It needs no parameters, because all points know their x coordinate and their y coordinate. So those are the instance variables of that point. So what this would look like is some println, some system.out.println, where we reference the x coordinate and the y coordinate. And what will happen is when we create the point, these are going to have specific values. So whenever we call print location, it just goes and looks up those values for that point and replaces x coordinate and y coordinate with those two values that are saved with that point. So this would give our point, this would print out, if we were to call this, it would print out 4, if our point lived at 4. Because this would be our x coordinate and this would be our y coordinate. And then translate. Translate might look like this. It's going to also have a void return type, because it doesn't return any information. It's just going to move the point around. It will change its state. But translate needs to get given two values, two integers, to move this point. Some amount of change in x and some amount of change in y. So we're going to go ahead and call those two changes dx and dy. And what should it do? Well, it should add on to our x coordinate whatever dx is. So, if we translate this, write 3, we would put a 3 into dx, and we would add 3 to its x coordinate, so whatever that is. And it should add dy to the y coordinate. So that's our translate function. That's all it does. It just adds on to the x coordinate, whatever dx is, and it adds on to the y coordinate, whatever dy is. So let's. I'm going to pause here, and I'm gonna program this out in IntelliJ so we can see all this stuff in action and actually play around with the point a little bit. So go ahead and open up IntelliJ if you haven't already. Here I've got a point class and a point runner class. Point is going to be my class for where I create the blueprint, and then point runner is where I'm going to use points and translate them and print them out and so forth. So the first thing that goes at the top of the point class is the data. So we're going to have an x coordinate and we're going to have a y coordinate. And then the next item that usually goes in the class is the constructor. So we'll write constructor, and you can have more than one. We'll talk about multiple constructors in the next lesson. So let's write a basic constructor, public point int x int y, and this sets the x coordinate to x and the y coordinate to y. This is what we wrote down earlier. And then we have our two methods that we have, public void print, let's call this print location, and this prints out parentheses followed by the x coordinate, followed by comma and a space, followed by the y coordinate, followed by closing parentheses. So you notice that these member variables or instance variables are purple, and that's good that it reminds you of with this color that they are instance variables. So you'll see local variables don't get a color, whereas instance variables are bolded and colored slightly purple. So that's a way to remember that it's an instance variable and it belongs to a instance of a point. Now we'll look at, we'll write translate as well. Translate int dx, int dy. And what does this do? It changes the x coordinate by dx and it changes the y coordinate by dy. It adds those amounts to it. So that's a basic point class. It's got the two ints to keep track of its x and y location. It has a constructor and it has a print method and a translate method. So let's go ahead and play around with some points in our other point runner class. So first up, let's create a couple points. We'll create P1, and that's at 1, 2. And let's create P2, which is at the origin, 0, 0. Okay, so we've got P1 and P2, and we'll go ahead and print them out. So we'll say P1.printLocation and P2.printLocation. And if we run this, we should see 2 points, 1, 2, and 0, 0 get printed to the console. And there you see, P1 got printed. The first print was on P1, so 1, 2, and P2 got printed 0, 0. Now let's go ahead and translate P1. Let's translate it 3, 2. And so after translating 3 in the x and 2 in the y, P1 should be at 4, 4. So we'll go ahead and print its location after we've translated it. So we'll say, let's say a little bit more here. Let's say system.out.print is at, and system.out.print P2 is at, and then we'll say system.out.print after translation, and we'll print all these out now. So P1 is at 1, 2, P2 is at 0, 0. After translation, P1 is now at 4, 4. And so you can see this is a very useful tool that we've got these objects are holding on to the information that they need to know about to accomplish their tasks. In this case, their tasks are very simple. It's just print where it is and move it around. Okay, so the next time we're going to look at static keywords and also what the private keyword and some object-oriented programming concepts that you'll need to know in order for objects to kind of make more sense, because as our programs get more complicated, we get more and more objects, and how do we get these objects interacting with each other nicely? That will be the theme of the next video. So I will see you guys next time.